Welcome guys to another video on microeconomics. In this video, we will talk about the concepts of return to scale, which is one of the basic concepts in theory of the firm and more specifically in production function. And what is the return to scale means? So return to scale is the change in output due to change in all input by same amount. Or in other words, if we change all inputs in our production by same amount of t, what will happen to the output level? If we have a production function, y is some function of L and K, which in this case we have only two input, which is labor and capital. So if we change or if we scale all input by same amount of t, what will happen to the output level? There are three outcomes possible, which each of them called constant return to scale, increasing return to scale, and decreasing return to scale. The concepts of constant return to scale means if we change all input by same amount of t, the output level change exactly by same amount of t. What does it mean? If yt, this is a notation for the new output level after the change in all input. So it means yt is equal to f tl tk, which is new production function after changing input level. If the new production function is equal to t multiplied by the previous production function, which this previous production function is exactly equal to y, then instead of f of lk, we can write down y. So it means the new output level is exactly changed by the same amount of t. It means here the yt is equal to ty. It means the new output level change exactly by the same amount that we change our input level. So this is called constant return to scale. For example, as a practical example, if you have a burger shop, one burger shop, two employees, and some machine or some like equipment in this burger shop. So if we establish another burger shop with the same capacity, with the same quality of labor or employees, with the same quality and quantity of equipment, so we will produce exactly in a new shop the same amount that we produced in the previous shop. So now the new output, which is the combination of the previous shop and new shop output, will be like double, because now we have two shops, so the production level will be double. So if we produce like 100 burgers by one shop before, now we produce 100 burgers by another shop, so 100 plus 100 is 200. So we doubled our input level, so we doubled our output level as well. So it's constant return to scale. Another concept is increasing return to scale. What increasing return to scale means, in this case, the yt, which is the new output after scaling, is equal to f of tl tk. It means we change all input by same amount. It's greater than t of y of L and K. It means, what does it mean? It means if we change all input by same amount of K, the output that we have now, we produce now, is more than the change in input. So if t of f of L and K, which is exactly equal to the y, so now it's equal to t y. What does it mean? It means yt, our output after scaling, is greater than ty. Is greater than ty. So it means the new output that comes out, as a result of changing our input by same amount, is more than the change in input. So it means if we double the input level, the output level increased by more than double. For example, let's see as a telephone connection between two houses. Now, when we have one line which connect two houses, So it means here we have one connection. We have just one connection. So now when we bring another house, which is the third house in here, so when we add up one extra input, which is like a telephone here, so the output, now we should have two connection line. But here we have three connection line, one connection between the first house, second house, one connection between the second house and third house, one connection between the first house and third house. So the output increased by more than what we change the inputs level, which is called increasing return to scale. And the next concept is decreasing return to scale. And decreasing return to scale, again, when we scale our input, which is the new output is equal to YT, which come from the results of scaling in all input, which is TL and TK, it increased. Now output level increased, but it's less than what we change the input level, T multiplied by F of L and K, or is equal to YT. So in this case, the last case, the YT, the output after scaling is less than TY. What does it mean? It means if we double our input level, the output level increased, but by less than double. The output level increased by less than double. Another example in this case, for example, if we have one small hospital and we serve 100 patients or clients each day, so if we make a bigger hospital, so what do you think? We will serve 200s, more than 200s? Maybe, but not in all cases, because when we make our hospital now bigger, so rather than like only doctors, nurses, equipments, so the management will become more complex. Serving more patients or more clients will be much more difficult. So in this case, although our new hospital is 2 times bigger than previous small hospital, but we cannot serve double clients here. So it's a concept of decreasing return to scale. I hope this concepts of return to scale and 3 types, which is increasing return, which is constant return to scale, increasing return to scale, and decreasing return to scale is clear for you. And the next video, we will solve some questions related to return to scale to show what kind of production function may exhibit constant return to scale, increasing return to scale, and decreasing return to scale. And also we'll solve some numerical example as well to be more clear about the concepts of return to scale. For now, this is it. Thank you so much for watching. See you next time.